Hi Math 2, this is Unit 6, Lesson 10 notes. Hi Math 2, if you could turn in your workbooks to page 76, this is parallel lines in a plane. So we're going to graph a few lines to get started. So let's write down three equations here. I'd like you to write down the equation y equals 1/2 x plus 3. I'd like you to write the equation y equals 1/2 x plus 1, and y equals the equation 1/2 x minus 2. These three equations are in our slope-intercept form. That is our y equals mx plus b form. So in each of these, I know the slope and I know the y-intercept. So let's graph them. The first one has a slope of 1/2 and a y-intercept of 3. So in my graph, I go up to my y-intercept of 3 and I put a dot, and then I use my slope. It's a movement of 1 up and 2 to the right, and 1 up and 2 to the right. And I can also go the other direction by doing the reverse movement, 1 down and 2 to the left, because that's a negative movement, and a negative over a negative would be a positive. Again, I could go down 1 and 2 to the left as well. And that creates, if I draw a nice neat line, that would be the graph of y equals 1/2 x plus 3. Let's take a look at the next equation. My slope is 1/2 and my y-intercept is a positive 1. So let's go to my y-axis and graph my positive 1 and then use my slope. Again, up 1 to the right 2, up 1 to the right 2. I could also do the reverse movement, down 1 to the left 2, down 1 to the left 2. And again, I can draw a nice line through my points. And the second line would be the graph of y equals 1/2 x plus 1. And finally, let's graph our last equation. My slope was 1/2 again, and my y-intercept is -2. So I'm going to go to -2 on the y-axis, that's my y-intercept, and now I'm going to use my slope. Up 1 over 2, up 1 over 2, down 1 over 2, down 1, left 2, and I can draw in the equation of that line. These three lines are all what we like to call parallel. Parallel lines have the same slope. And then parallel lines never intersect. So we're going to be talking about parallel lines today. And so we're going to be talking about lines that have the same slope. So if you could turn to page 78, I'm going to use the very first question that your workbook has. So notice that your workbook on page 78, number 1, says write the equation of a line parallel to y equals 2x plus 3 passing through this point. But then notice my next questions 2 through 4 are not the same as in your book. You can cross out your workbook's numbers 2 through 4, and instead we're going to do a different set of 2 through 5. Number 5 is on the next page. So anywhere on page 78, you can write these new problems. We'll get to those in a moment. So let's go back up and look at number 1. It says write an equation of a line parallel to this line passing through this point. So with this problem, we're going to use our new equation we learned in lesson 9. That was my point slope formula. So point slope formula is what we learned in lesson 9. That was y minus k equals my slope times x minus h, where my point on my line is hk and my slope is m. So let's try that here. So if it's parallel to y equals 2x plus 3, this is y equals mx plus b form. I know that my slope is 2. You can think of it as 2 over 1 if you wanted to. And I know it passes through this point, and this point is my hk. So the equation of this line would be y minus k, or y minus my y coordinate of 1, equals my slope of 2 times x minus my h, or x minus a negative 4, would be x plus 4. This is the equation of the line that's parallel to y equals 2x plus 3 and goes through this point. So let's try another one. Please write this on your page, number 2. Write the equation of a line parallel to y equals 2/3 x minus 5, passing through 0, 2. So this is my y equals mx plus b form of my equation. So I know that my slope is 2/3. In order for my line to be parallel, they have to have the same slope. So I know that my slope is 2/3, and I know the point that it goes through, my hk, is 0, 2. So now I can write my equation. Y minus my k, y minus my y coordinate, y minus 2, equals my slope 2/3 times times x minus h, which is 0. This equation is fine. That's a great answer. Some students will notice that x minus 0 is just x. So you could also write y minus 2 equals 2/3 x. They're really the same thing. So let's take a look at number 3. Please write this entire sentence down in your book on page 78. Write the equation of a line parallel to y equals negative 4x plus 5, passing through negative 2, 7. So again, this is my y equals mx plus b format. So I know my slope is negative 4. This is the point it passes through. I know this is my hk. So I'm ready to write the equation of my line. So the equation of my line would be y minus my k, which is 7, equals my slope, which is negative 4, times x minus a negative 2, which is really x plus 2. So let's take a look at number 4. Please write this entire sentence on page 78 of your book. Write an equation of a line that passes through negative 1, 2, so this is my point hk, and is parallel to a line with x-intercept 2, 0 and y-intercept 0, 3. Well, wait a second, it's not telling me the slope. So it looks like I'm going to have to calculate my slope. So just as a reminder what my x-intercepts and y-intercepts are, that means that my line goes through 2, 0 on the x-axis, and it goes through 0, 3 on the y-axis. So 1, 2, 3. So this is my line right here. This is the line that I am trying to write an equation that's parallel to. So I'm going to calculate the slope of this line, but I'm going to use the slope formula from our formula sheet. The slope formula from our formula sheet says y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So if I'm not given a graph and I can't do slope triangles, I could use my 2 points. One of my points is 2, 0. My other point is 0, 3. And I could calculate the slope. It doesn't really matter which y I start with. I could use this 0 first, or I could use this 3 first. That's up to me. But whatever y value I use first in the numerator, I'm going to use that x value first in the denominator. That's the only thing I have to be careful of. So I'm going to go ahead and use the 0 first. So 0 minus 3, those are my two y values, divided by now the difference in my x's. So I got to start with my 2, since I started with the 0 on top. 2 minus the other x value is 0. So 0 minus 3 is negative 3, and 2 minus 0 is 2. I want to talk about that slope for a moment. Sometimes students don't know where to write the negative, so I want to make sure you understand that whether I write it as a negative out in front of 3 halves or I write the negative up with the 3, or I happen to write the negative down with the 2, it doesn't matter. Those are all the same number. That is a negative 3/2. So just for convention's sake, I'm going to write it in this manner. But technically, all 3 of those fractions are completely equal. So now I have a slope. My slope is the negative 3/2, and I have the point negative 1, 2. So I can write my equation. Y minus 2, my k value, equals my slope, negative 3/2, times x minus a negative 1, or x plus 1. So I have one more problem I'd like you to write on this page 78. Please write number 5 as our final problem on page 78. Write an equation parallel to 3x plus 4y equals 7 and goes through 4, 1. And I want us to try to write it in point-slope form, and I also want us to write it in slope-intercept form. So to begin, ladies and gentlemen, notice that I don't know my slope. So I'm going to have to use my equation to find my slope because I'm not sure what it is. So let's talk about how to do that. This is standard form. Standard form for the equation of a line is my ax plus by equals c. So in this case, I've got 3x plus 4y equals 7. So if I want to find the slope, I'm going to use my algebra to solve for y. If I solve for y, what I get is y equals mx plus b, and then I can see what my slope is. So let's begin solving for y. The very first thing I'm going to do to solve for y is move my x term to the other side by subtracting 3x from both sides. So I get 4y equals negative 3x plus 7. Sorry about that. So I can't combine those because negative 3x and 7 aren't like terms, so I'm going to leave them separate. And then I'm going to divide both sides by 4. And when I do that, I'm going to divide each term by 4. So I get, when I do that, y equals negative 3/4 x plus 7/4. I want to talk about the negative 3/4 x. Sometimes students get confused here. Negative 3/4 multiplied out in front of the x is the same thing as negative 3x over 4. So whether I pull the negative 3/4 out in front as a coefficient, or whether I let the x go in the numerator because it's really x over 1, it doesn't really matter. We're used to looking at it in this format where the numbers are pulled out in front as a coefficient, because now I know this is my m. I know that my slope is equal to negative 3/4, which is what I wanted from this. So I'm going to write it in that way. So coming back over to my problem, I now know that my slope is negative 3/4. So I know that in point slope form, this is y minus 1 equals negative 3/4 x minus 4. So now to put it in slope-intercept form, I've got to use algebra again. I need to solve this for y. So just like I did before with a different equation, I'm going to solve for y. And when I do that, it's going to be in the form y equals mx plus b, which is what I want. So my algebra for that, my first thing, if you remember your algebra, is over here. I'm going to distribute my negative 3/4 to get rid of the negative 3/4 times the quantity x minus 4. So nothing happened on my left side. And so negative 3/4 times x is negative 3/4 x. And negative 3/4 times this negative 4 off to the side, negative 3/4 times this negative 4. The 4 is really over 1. So technically, you're getting negative 12 over 4, which is negative 3. Or some of you might notice that you could cancel along the diagonal and you get your 1s, which is still negative 3. So when you distribute this negative 3/4 times negative 4, we get negative 3. Although there's a couple ways you could show your work, and I'm not sure which way you prefer, but both of them work. So now again, I'm not done. I haven't solved for y. So now I'm going to add 1 to both sides. And when I do that, on my left side, I get y equals negative 3/4 x, and negative 3 plus 1 would be negative 2. So this is another way to write the equation of this line. They're both the same line, they're representing the same graph, but it's just a different form of the equation. So the last thing I'd like to talk about is, or the second to the last thing I'd like to talk about is on page 79. If you could look at this graphic in the summary, for each one of these 3 lines, I'd like to write the equation of the line in A, slope-intercept form. That's my y equals mx plus b form. And I'd like to write it in point-slope form. That's my y minus k equals m times x minus h form. So let's take a look at each line and find out everything I need. First of all, I need my slope. And I need a y-intercept. So for this problem, my y-intercept is 5, and my slope, I go over 2 in the positive x direction, and I go down 1 in the y direction. So it looks like my slope for this line is going to be negative 1/2. So if I want to write it in slope-intercept form, I have y equals negative 1/2 x plus my y-intercept, which was 5. My line crosses the y-axis at 5. So now I would like to write it in point-slope form. So I need a point on my line. Let's use the point they give me. This point right here on my line is 2, 4. So now I'm going to write it in point-slope form. So y minus the y-coordinate, y minus 4, equals my slope, negative 1/2, times x minus my x-coordinate, which is 2. That's 2 different ways to write an equation of this dashed line. Let's take a look at the middle line. So we'll take a look at the middle line right here. So in order to write the the slope-intercept form, I need an intercept. Looks like it crosses the y-axis at 3. And again, my slope is the same, 2 to the right, down 1. So my slope is still negative 1/2, and my y-intercept is 3. So my slope-intercept form would be y equals my slope, negative 1/2, times x plus 3 in this case. And for B, I need a point to use with my slope. So let's use the point that they identify. They identify, what is that point? 2, 2. So let's write the equation in point-slope form. So this would be y minus my y-coordinate of 2 equals my slope, negative 1/2, times x minus my x-coordinate of 2. Great. So let's take a look at the third line. So this third line, again, has the same slope. I can see it's to the right 2, down 1. So my slope is still negative 1/2. And now my y-intercept is negative 1. So to write the equation this line in slope-intercept form, it would be y equals my slope, negative 1/2, x minus 1. Great. So I can also write this equation in point-slope form, but I need a point. Any point will do. Let's use the point they give me. So it looks like they give me the point 2, negative 2. So my equation in point-slope form would be y minus a negative 2, which is a double negative, so it's really y plus 2, equals negative 1/2 x minus, I forgot parentheses, negative 1/2 parentheses x minus the x-coordinate, or minus h, which is also 2. So, and before we leave the screen, I want to talk about how the point-slope form is the same as the slope-intercept form. So let's use this green equation. This y plus 2 equals negative 1/2 x minus 2. I can solve this for y. So what we've done a couple times is we've solved for y. I could do that again. I could solve this for y. I better get the same equation that was in A. So let's see if I do. Remember my first step, it was to distribute the negative 1/2. So I get y plus 2 equals negative 1/2 times x. Now I've got a negative 1/2 times a negative 2. Off to the side, negative 1/2 times a negative 2, and that's a negative 2 over 1. So you could see where I have a negative negative, which is a positive, and I get 2 over 2, and 2 over 2 reduces to 1 over 1 or 1. So I would get a plus 1 right here. Now, we're not finished yet because we haven't done what we set out to do. We haven't solved for y. So in order to solve for y, I would need to subtract 2 from both sides. And when I do that, I get y equals negative 1/2 x minus 1. Notice that this is the exact same equation that I have in A. So I just wanted to point out that whether you write it in slope-intercept form or whether you write it in point-slope form, this is the same line, this is the same equation. And all three of these lines were parallel and they all had the same slope of negative 1/2. So at this time, I'd like to take a look at a problem in your homework. This is on page 80. This is your practice. It says prove ABCD is not a parallelogram. So I want to remind you for a moment what it means to be a parallelogram. So my opposite sides have to be parallel. And in this lesson, we learned that parallel lines have to have the same slope. But I can look at AB and I can look at CD and I look at those two lines and they don't really look parallel to me. They don't look like they are the same slope on the graph. So let's check that out. So I'm going to try to find the slope of AB. I want to see what that is. So let's check this out. To go from A to B, looks like I'm going over 3 and I'm going up 1, 2, 3, 4, 5. So the slope from A to B would be 5/3. Remember, this is your rise and your denominator is your run. So the change in y was 5, it's my numerator, and the change in x was 3, it's my denominator. So let's go look at the slope of CD. Okay, so when I draw my slope triangle for CD, it looks like my horizontal change is 1, 2, 3, 4, and my vertical change is 1, 2, 3, 4, 5. So my rise or my vertical change, my y change is 5, and my run, my horizontal change, my change in x is 4. So notice that 5/3 does not equal 5/4. So ABCD is not a parallelogram. I'm abbreviating parallelogram with the symbol for parallel because AB and CD do not have the same slope. Okay, I will see you in Zoom. Thank you so much.